Assalamu alaikum and dear students, today we are going to solve exercise 1.5. Here first question is, find the determinants of the following matrices. In first, matrix A is equal to elements negative 1, 1, 2 and 0. That A is equal to determinants of matrix A is equal to determinant of elements negative 1, 1, 2 and 0. That is equal to first entry is obtained by the product of principal diagonal elements negative 1 time of 0 minus second entry is obtained by the product of other elements 1 time of 2. That is equal to negative 2. In second, matrix B is equal to elements 1, 3, 2 and negative 2. Similarly, that B is equal to determinant of matrix B is equal to determinant of elements 1, 3, 2 and negative 2. That is equal to first entry is obtained by the product of principal diagonal elements 1 time of negative 2 minus second entry is obtained by the product of other elements 3 time of 2. That is equal to negative 8. Similarly, 3C is equal to matrix having elements 3, 2, 3 and 2. Determinant of C, that C is equal to determinant of C is equal to determinant of elements 3, 2, 3 and 2. That is equal to 3 time of 2 minus 2 time of 3. That is equal to 0. Question number 2. Find which of the following matrices are singular or non-singular. In first, matrix A is equal to elements 3, 6, 2 and 4. Determinant of matrix A, that A is equal to determinant of matrix A is equal to determinant of elements 3, 6, 2 and 4. That is equal to 3 time of 4 minus 6 time of 2. First entry is obtained by the product of principal diagonal elements 3 time of 4 minus second entry is obtained by the product of other elements 6 time of 2. That is equal to 0. So matrix A is singular. In second, matrix B is equal to elements 4, 1, 3 and 2. That B is equal to determinant of matrix B is equal to determinant of elements 4, 1, 3 and 2. That is equal to 4 time of 2 minus 1 time of 3. That is equal to 5. So matrix B is non-singular. In third, C is equal to matrix having elements 3, 2, 3 and 2. Determinant C is equal to that C is equal to determinant of matrix C, that is equal to determinant of elements 3, 2, 3, 2. That is equal to 0. So matrix C is singular. In third, find the multiplicative inverse if it exists of each. In first, matrix A is equal to elements negative 1, 3, 2 and 0. A inverse as shown. In first, we find the determinant of matrix A, that is equal to determinant of elements negative 1, 3, 2 and 0. That is equal to negative 6. Adjoint of a matrix A, that is equal to matrix having elements 0, negative 3, negative 2 and negative 1. A inverse is equal to matrix having elements 0, 3, negative 2, negative 1 over negative 6. That is equal to A inverse is equal to matrix having elements 0, 1 over 2, 1 over 3 and 1 over 6. In second, B is equal to matrix having elements 1, 2, negative 3 and negative 5. Multiplicative inverse of matrix B. B inverse is equal to adjoint of a matrix B over B determinant. Determinant of matrix B is equal to determinant of elements 1, 2, negative 3 and negative 5, that is equal to 1. Adjoint of a matrix B is equal to matrix having elements negative 5, negative 2, 3 and 1. B inverse is equal to matrix having elements negative 5, negative 2, 3 and 1 over 1. B inverse is equal to matrix having elements negative 5, negative 2, 3 and 1. In third, C is equal to matrix having elements negative 2, 6, 3 and negative 9. C inverse is equal to adjoint of a matrix C over determinant of matrix C. In first, we find determinant of matrix C, that is equal to determinant of negative 2, 6, 3 and negative 9. First entry is obtained by the product of the principal diagonal elements negative 2 times of negative 9 minus second entry is obtained by the product of other elements 6 times of 3, that is equal to 0. Multiplicative inverse of a matrix C is impossible because determinant of matrix C is equal to 0.